Our next speaker is Anderson. He went from hobby to profession coding since he was a teenager, first for fun, then university academic research, and now on the free market. He's worked with many different languages and paradigms on startups from fintech to the travel industry, breaking monoliths into reliable microservices. Currently, he's at BlackLane, helping the company to adapt Go and to replace the old monolith with an event-driven architecture. And that's what his talk is going to be about. Welcome, Anderson. Stage is yours.
Thank you very much, Tim, for the introduction. Let me share my screen. Oh, yeah. Okay. Yeah, so good evening, everyone. Today I want to talk a bit about how was this last year in BlackLane. We were migrating from the monolith to event-driven architecture. So who am I? I mean, Tim introduced myself quite well. Thank you very much. But I'm Brazilian. I'm here in Berlin since 2018, and I'm working with Go for some time. So the idea today is really almost to tell some anecdotic tales, some things that we're discussing, concepts in our teams while we were doing this migration to event-driven architecture, right? And of course, we're going to start a bit of some context of what was before and how we did this migration and where we are. So let's go. So as I said, a bit of context. So we are a global chauffeur company service. So you can order a BlackLane chauffeur pretty much everywhere in the world. Before the pandemic, we only had pre-booked rides. So you had to book in advance, 24 hours. We could do with less, but it was not so good for business. And the majority of the rides, they were airport pickups, right? And one of the reasons, because it's super predictable, an airport pickup. But other places that we're going, not so much, right? And definitely our long-term vision is much more than just rides, right? We want to make travel as easy as possible, peace of mind. And so we want more things, have more products, right? But so BlackLane was built around Ellie, our monolith, a Ruby on Rails application that this concept of ride, it's Ellie itself, right? Ellie and rides are almost the same thing, you could say. So we can't really just add a new product there. It's super hard. And also just refactoring is not enough, right? So of course, as most of the startups, we get to the phase, okay, let's break the monolith, right? In order to do so, we created a HT project that had the mission to create an event sourcing-based design that connects our front-end services with our core domain services. The idea is to create a meta team, so we got people from different teams to experiment with this new architecture. But then, luckily, we finished this project before the pandemic hit, but then the pandemic hit. Right, travel industry went to almost a completely halt. BlackLane bookings were on almost zero, and the roadmap and priorities didn't make sense anymore, right? And then we needed to reinvent ourselves and get ready for the recovery. And this was the opportunity that we took to say, like, now that we had to stop, right? Stop is not an option. We just stopped because the world stopped. We can take this opportunity and build a new product in a new architecture, because the old is almost not being used and it's fine. All the new features and everything that we plan to move slowly doesn't really make sense anymore. So we did like almost a radical shift and say, okay, let's build one of the products that we always wanted, that's to sell on-demand rides. That now it's called chauffeur hailing as the product. So we're going to use the domain-driven design, event source architecture, CQRS, vertical slicing, so we could have all the teams working together at the same time, delivering small deliverables So you could see the whole thing working since the beginning from top to the bottom of the architecture based on the learns of Tahiti, right? So it's a greenfield project. The communication between the bounded context domains must be through events using Kafka and use asynchronous communication as much as possible, right? So I think the only formal definition that I'm going to give today. So okay, we're communicating through Kafka as an event, but what exactly is an event? This formal definition by Greg Young, an event is something that has happened in the past. All events should be represented as verbs in the past tense, such as customers relocated, cargo shipped, or inventory losses recorded. For those who speak French, it should be passé composé. They are things that have completed in the past. Super short explanation. The event sourcing idea is instead of having one row in a database, right? You have a series of events, a series of events that they together, when you look at everything, they are this entity evolving through time. So we have like the first version, and then you have an edit on something, and it goes evolving. And if you want to know the current state, you go and apply everything. And then you get the current state. Just a second. Sorry, not COVID, just allergy. And yeah, so this is the domain events, right? So we are publishing what's happening with an entity over time. Oh, good. And then let's go to some challenging learnings. Why you basically made everything change from slowly breaking, building microservices to suddenly everything is microservices. Now it's Go, and now it's event sourcing. One of the first things that happened, so, okay, let's use Kafka in asynchronous communication as much as possible, right? So just felt that HTTP was like a sin and you couldn't do that anymore. And quickly we solved things. One service emits an event, full thing requested, and the other service listens to it, processes it, and then emit full thing response. And then the service that emitted the requested event consumes the response. Well, this is not quite event sourcing, right? We are doing HTTP over Kafka. It's not quite what we want. And this was interesting thing. The whole engineering team was super eager to embrace the new thing and go Kafka events. But at the same time, we had to say, okay, calm down. Not everything is asynchronous. We still have good space for the HTTP. The good part of the query in Queiroz most of the time are really going to be just HTTP requests. You just want one information or request something to get a response, right? So even a synchronous event-driven architecture, there is still good space for HTTP synchronous communication. There is need for that as well. Both stuff, they live together. Yeah, just what I just said. Another thing, so this is one thing. So another thing that suddenly we have a series of services, they need to cooperate, right? And they are communicating through events. The events are proper events now, right? But still, how many topics, right? Who publishes on topic? Who consumes on a topic? And quickly we got to things like, okay, I said like BlackLane sells rides. So here the context is we have a ride, we have a pickup, a drop off, and you have to find a chauffeur to fulfill this ride, get the gas from pickup to drop off. And then we have a rides domain, a ride service, and it emits an event ride created. The request came from the front end, from our GraphQL, and so on. The ride matcher finds the chauffeur and publishes a ride chauffeur assigned. And then the ride service updates the ride. Not quite, right? The idea looks fine. We are seeing here proper events. But if you really think about it, what they just did was like two different services. They are editing, they are changing the same entity. That's a ride, right? If you think about a normal relational database, what we just did was having two services changing the same row in the same database. It's not, not even talking about accessing the same database. They're changing the same row. It's not quite what we want, right? We want to separate. And on this example, there are two domains actually that are interactive with each other. One is super easy to see. They're the rides. That a ride is up, pick up, drop off a gas in a chauffeur, right? And the ride entity is taken care by the ride service. That's fine. We have another thing that's the whole ride fulfillment. There are a lot of stuff going on, right? Tracking chauffeur position, right? Seeing if the chauffeur is active, it's online, sending position, so on. Which chauffeurs are closer to go to fulfill this ride, right? This is another thing that's happening. And then we start to see, okay, these are two different topics, right? You have the rides and the rides entity. This is super easy to see, and anything that's published there happened, and it can only be done by the ride service because these are changes in a ride. And now we have these two services where the ride service published the ride created. The ride matcher listens to it and publishes event chauffeur found. And now the ride can consume it because now indeed I have something. My ride matcher in this rides fulfillment domain found a chauffeur. And this event might be interesting to other things, right? To other services to listen. And now that ride service listen to chauffeur found, I can update the ride. And I can check if I can update the ride, because imagine the ride can be canceled, right? The service who owns the ride service is the really only one that say, okay, now that I have a chauffeur, can I really assign the chauffeur to this ride or not? If I can, great. So I just publish ride accepted. The other way around could have happened as well. Could be chauffeur not found or not available. And then I would have to say ride rejected, right? So this is another thing that definitely topics, names, and which events going in each topic. This was like huge discussions in the beginning. Now these concepts are more understood through the whole company, and it's easier. But we spend quite a good amount of time on that. Another thing that once we have things distributed so much, right, is the question, where is the data? At the beginning, and then when I say beginning, months, right, where just building stuff with vertical slicing, there is a lot of mocking going on. We are just really focusing on a small happy path. No one was asking questions about it. But once there's things starting picking up, people, but where are the rights? How can I acquire the right? What's the database that I am gonna access to it? And then, now, I mean, of course, we as a company knew since the beginning, we had people working on that since the beginning, but we see the work and people looking for data only later on, right? We really need to build a search service. Before, what we had were crazy queries against Alice database, making Alice database slow, or even like read replicas dedicated for our backoffs and stuff like that. But now, no, we have this distributed data, but they are distributed, but they are also events. So I can have a search service or search engine that listens to all the events, all the topics that I need, collects the data using Elasticsearch, index the needed data, right? And then now I can really search and correlate stuff. For example, now I can say, okay, given a chauffeur, which rides he did, or even given a guest, which rides he did, right? Or other more complex queries. Like, so as I said, we have rides, but also we have, on top of rides, we have bookings. Bookings is our shopping cart. All the products that we might get from BlackLane is within a booking. Right now, the only service that we have are rides. And you have two types, on demand and pre-booked. But in the future, you're gonna have more. So we can say, okay, given this booking, who is the chauffeur? So I have to find a booking, find a ride, and then find the chauffeur. And all this data is distributed. So the search engine knows how to correlate these, and it's basically using IDs and as little information as possible, right? So as I said, Ellie is still there. That database is still there. So when I'm talking here about chauffeurs and rides and guests, I'm basically talking about IDs. This new platform has got little knowledge about people, right? About a lot of stuff. There is a lot of knowledge about IDs. And the same thing goes to the search engine. Who owns the rides? Still the ride service. If you want to see how a ride is, you're going to query rides. Right? So what the search engine does is correlate all this data, send it back to GraphQL, a bunch of IDs, and GraphQL, through his resolvers, knows how to resolve them and which services to query which data. So our source of truth still being the domain services, they still being the source of truth for the domain. So rides, you go to rides, bookings, you go to bookings. And as we put more stuff and more services, you're gonna have more sources. Another thing is, with that, we have the possibility of plug and play stuff, right? And this is easy to see and to listen, but the first time that you get a feature, oh, this is just plug and play, that was like, feels so good. So one of the first things came was like, oh yeah, now that you're already live, right? Chauffeurs are performing rides, guests are booking, getting from A to B. Now we want to send to the chauffeurs that are performing on-demand rides an email after the ride. And then this is great. We have the rides topics. We can just build a service that listens to ride finished and then gathers all the data that's needed. That's going to basically be the ride, some chauffeur information. And now, unfortunately, we have to go to Ellie, but then we also have API. So this service is going to listen to event, gather some data from other services, put it together, and send the email. And nothing else in the platform is affected. If tomorrow I want to throw away the email and do something else, I can. I didn't have to go into the rides service code and say, oh yeah, on ride completion, also send something here or there. Because the beauty of that is like the relationship now is reversed. You don't, a lot of things, instead of you have to be poking every single service to say something must happen, these services, they can listen to changes in the whole platform, right? Of course, depending, as I said, like there are still space for synchronous communication. There are some coordination that needs to be done. Sometimes you need to poke someone to get something, but it's not always. Yeah, this was some like more high level discussions that we were having while we were sedimenting these concepts with the engineering. But also, this is a Go Meetup, and there was a lot of Go code happening. And when you started we're gonna go to use any sort of message broker, right? And you start to go to see the libraries and the example codes, how to use it. I hope the images are in a good size. But basically, what you're given is a for loop, right? An infinite for loop, a method that receives message, and that is it. And most of the time, they only print the message, right? Some not even have a for loop in the example. They just receive the message, they do something, and they create the program. And this is just too raw, right? Sorry. We needed more abstraction to be able to work better. And now also we have like several teams working with that at the same time. One really well-known abstraction that has been working for a long time is HTTP, right? We are well familiar with request responsive handlers with middlewares. And so what we did is like to adapt this concept and use the same terminology to build an events library an abstraction on top of Kafka that would allow us to handle events almost in the same way that we handle HTTP requests. Because at the end of the day, consuming an event and receiving a request is just an input that needs a process and it might yield an output, right? Of course, on the HTTP, there is always a response. On this case, we might produce some event or not, but it's an input and this is a process. So here just a bunch, I'm going to show a bunch of snippets from these events libraries that we made that would allow us to use basically the same logic, right? So just a event type, and then most of the message broker, they have headers and a payload that can be anything, a handler interface that receives the event and the context, returns an error. Also helpers, the handler func that we all use a lot, and also a definition of a middleware, just to have a middleware type. And with that now, I can use middlewares again, right? I can register handlers easier. And the main gain that we had with the middlewares concept, it was definitely the greatest gain here, is because now it's super easy to add a logger, right? To have a logger with a tracking ID or any sort of tracing, right? Because even though the process is asynchronous, I still want to trace how things jump from one service to the other. I still want to see, okay, one thing is one request from the front end, it spawned a series of processes on the back end, and I wanted to trace it together, right? And on the HTTP world, it's super easy, right? There's all sorts of tools, open trace, and so on that are already built to work with the HTTP protocol. But when we go to messages or events, you have to do some more work, right? And now using this library and having the middlewares, we can just put everything inside the middleware the same way that we did on the HTTP and give it to all the teams and move faster, because not everyone has to build their own middlewares, right? And also remember that we are migrating from Ruby to Go, so not everyone is super comfortable with Go, right? There was also a good process of teaching Go, spreading Go knowledge throughout the company. So this has helped a lot, so because people could plug and play stuff and move faster. Yeah, and here just a bit of the first implementation of what would be the equivalent of the HTTP server that you send to run. It just consumes messages and uses a Go routine to call the handlers in a Go routine. And you have here a waiting group, so we can do graceful shutdown. So you can wait all the handlers to finish processing before quitting the application. Yeah, as I said, like it works. It allowed us to move faster. We can integrate APM, tracer, or anything quite easily. And having as a library, and also we have the HTTP version of this middleware. So it's super easy to keep the standard and ensure that both are working in the same way in together. Of course, this is a early version, an experiment, and a naive implementation. So we already have some learnings from that, right? It's super generic, and from the company's perspective, we see some patterns that they rose, and they are well suited to be in the library, because at the end, the types are so generic that the teams had to build an abstraction on top of the abstraction. But now also after some time, we can really see what it's solid and is really well used. And now we're going to start to update the library to incorporate that part that's already an abstraction that the teams are used, right? Instead of forcing them to use a specific abstraction. Also, the fact that every time that a message arrives, we launch a Go routine to process the event. This by itself is not a problem, because unless if you do something really heavy or so on, you're gonna have thousands of coroutines, even more in a program with no problem. However, you are delegating to the Go scheduler to run the Go routines. And then, even though if the message they're gonna arrive in the right order, they might not run in the right order, right? You know that the Go routine is gonna run. You don't know when. There are some services, they have zero problem with that. Other services, they have more problem with that. So it was one of the, let's say, major updates that we had to do in the library, that's to ensure, to allow some sort of sequence to happen, right? So we built a functionality that given a key for an event, we guarantee that the next message with the same key that arrives in this service, it's only gonna run when the first finishes. So we are creating some contingencies and making stuff to run sequentially, right? But only for the same message key, so that there are entities that are correlated. So in the right example, so every time that you consume a ride event, for the same ride they run, you process them sequentially, right? So this is useful for some services. And this was something that we also made optional. So the library doesn't enforce that because it's not needed for everyone. And then, of course, when you try to create an abstraction on top of bigger things, it's hard. So it's not quite possible. It's possible to abstract Kafka 100% away, but it's not worth the effort, right? So the library is actually pretty good in the sense that we don't import any Kafka specific code, any code for the underlying Kafka library into your code, but you do use some specific Kafka concepts, right? If you would migrate, it might not be the same thing. But also, it's not quite likely that you're going to just throw Kafka away anytime soon. Now, yeah, that was that. I hope it was interesting, and I'll be happy to ask any questions about what I talked, or even about the new architecture, the process, whatever you may want to ask. And all these slides, they are going to be on my GitHub, and my contacts are here as well.
Thank you very much.